Welcome to the Nokia Optical Networking Learning Essentials video series from the Nokia Optical Network Certification Program, an end-to-end learning program supporting Nokia 1830 PSS, VWM, and NFM-T based networks. Today, we'll take a look at link redundancy via Ethernet ring protection, or ERP. This video has been created based on the Nokia Integrated Packet Transport over WDM course. In this video, I will provide an overview of the ERP mechanism to provide redundancy over ring network topologies. We will see that ERP carrier-grade solution has a fast convergence time below 50 milliseconds and enables the operator to administer and control its resources. We will also connect to labs and demonstrate how to implement ERP across multiple ring topology using the Ethernet Service Manager, a tool included in the Nokia NFM-T platform to manage Layer 2 devices. Redundant links are used to provide protection and reliability over Ethernet-based transport networks. The use of redundant links may introduce loops that may lead to instability in the MAC address table of the interconnected devices. The popular spanning tree protocol is often used to prevent loops, but has a slow convergence time, especially on wide topologies. To improve convergence time, the ITU-T has standardized a universal protocol that ensures good compatibility and is based on the most widespread transport technology, that is, Ethernet, which guarantees fast network convergence time. ERP also supports a set of administrative commands. Like spanning tree protocol networks, ERP keeps one link blocked to prevent loops. This designated link is called Ring Protection Link, or RPL. The RPL owner, a designated provider edge, or PE, is responsible for blocking traffic over the RPL ports. The ring protection mechanism achieves loop avoidance by ensuring that at any time, traffic flows on all but one of the ring links. Under normal conditions, the RPL is blocked and not used for traffic. The nodes involved in the ring use the Ring Automatic Protection Switching, or RAPS, protocol to coordinate the protection actions over the ring. Every time a failure occurs, ERP blocks the port facing the failed link and triggers the RAPS signal failure message to be sent to the adjacent nodes. The RPL owner is responsible for unblocking the ring protection link and allowing traffic to be forwarded over the blocked link. Any given network without open ends can be represented as a multi-ring network, composed by major and subrings, where a subring is basically an open ring, not forming a closed loop, connected to a major ring through a pair of interconnected nodes. This slide shows examples of overlapping ring topologies where major and subrings build a nested infrastructure to ensure a better level of protection. To obtain the best design, each ring needs to be controlled independently from the others. That's why in multi-ring topologies, ERP introduces another design flexibility using virtual channels, or VCs. Each subring can be implemented using or not VCs. Each option has pros and cons and must be selected based on the specific topology. 1830 PSS Layer 2 packs, based on the popular Service Router operating system, support both VC and non-VC mode for subring control communication. The closed loop for a subring can be accomplished by implementing a virtual channel. In VC mode, ERP messages of the subring are tunneled from one interconnected node to the other and transmitted on the major ring. Usually, the VC mode applies to network topologies where subring links are not contiguous and cannot detect the change of state of each other. Also, this option allows operators to interconnect multiple Ethernet rings without the need to reconfigure the major ring as a subring. Virtual channels can also improve failover times if the subring is large, as it provides two paths on the subring interconnected nodes to propagate the fault indication around the subring. In the non-VC mode, subring messages are terminated at the interconnected nodes, hence there is no need for additional bandwidth. This in turn also offers less redundancy. Failover times might be extended since the fault indication may need to traverse the entire subring. Our target is to deploy a multiple ring topology protected by the ERP mechanism through the Ethernet Service Manager network configuration. First, let's start to deploy the major subring by running the appropriate template from the Best Practices folders tree. A second window will be displayed. From the first panel, we just need to set the ring name. In the Ring Topology pane, we're going to select all the involved links from the Link Selection dialog and define the RPL owner. Once done, from the ring protection pane, we could choose the revertive or non-revertive protection mode. Then, the Ethernet connectivity fault management feature can be enabled to improve link failures detection in addition to the signal fail condition. Most of the attributes can be set with default values proposed by the best practices template. Finally, it's time to deploy the major ring. Let's check the result from the Operate tab. Now we can move to the subring deployment. For the proposed topology, a virtual channel implementation can improve the ERP messages exchange. To do this, the ERP subring template must be selected. A new panel like the previous one is shown. We set the ring name and, more important, the subring configuration to virtual channel with the propagate topology change attribute enabled. From the ring topology pane, we select the main ring and the links participating in the subring open topology. Then we define the RPL and the RPL owner of the subring. In the protection type, like for the main ring, we select the revertive mode. Then Ethernet CFM can be enabled. Again, most of the attributes can be set with default values proposed by the template. Finally, let's deploy the subring template and check the result. Under the major ring instance, a second ring has been associated. Here, a graphical representation of the major ring is displayed from the routing display feature. Let's now summarize what we have seen so far. ERP is a popular solution for protecting Ethernet ring networks because of several benefits, such as the compatibility that comes from the ITU-T standard, a loop-free topology, a fast convergence time against failures, and the fact that it is a carrier-grade solution. Also, ERP can be implemented over multiple ring topologies thanks to the introduction of the virtual channel concept, especially for not contiguous open rings and the support of administrator commands to enforce network reliability. ERP implementation can be done with useful and user-friendly ESM best practices templates, already configured on NFM-T and available for the final user. Thanks for watching, and look for more videos in our Optical Networking Learning Essentials series. Whether your goal is to enhance your optical networking skills or demonstrate your expertise through one of our 4 industry-recognized certifications, the Optical Network Certification program is here to get you, your career, and your organization on the right path. Our program features 9 instructor-led courses developed by our team of subject matter experts using industry best practices, use case-driven examples, and hands-on labs. Learn more and get started today by visiting our website. Thank you.